Hey guys, welcome to another live stream. Joseph here from ChronoLogic, here with Piotr, who is going to tell us more about second layer execution markets. For those of you who were not here with us last week, we have gone through a presentation of Piotr's that Piotr will be giving on Ethis this week actually. And we have a bunch of other updates for you guys. So, you know, uh, so you guys just stay and listen, and hopefully you'll find this live stream interesting. So let's
Yes,
get straight
and
into it.
just one thing from my end. Hi guys. Essentially, even if you've been listening last week, this presentation is gonna be different. So stay tuned. It's like absolutely different. So uh,
Yes, so lots of updates, guys. Let's get into it. So from the development side, we have the updates to the app.chronology.network and our Electron TimeNode DApps. So we pushed a new release late last week called Release 1, our Release Candidate 3, and it includes a number of like robustness features. One of them is like improved transaction caching. The other one is some improved Electron experience. So we added an about page where you can kind of check which version of Electron app are you running and all this kind of stuff that was missing before. So we added full support for mainnet and Robston. So if you guys are running on any of these other two networks, it is now fully tested and working on these networks. So it is also based on the latest release of TimeNode Core. Same thing goes for the CLI, which is we pushed the new release 3.1.2 actually. I forgot to change it here, which is based on the new TimeNode Core release as well. And of course, the new TimeNode Core release introduces fixes to the errors that we've seen with watching the buckets. So for you guys experiencing these like watching bucket errors, it will not happen anymore. So another reminder we have is that this week ChronoLogic will be attending a couple of events. So the two of the events, we already mentioned them last week. So just kind of short reminder that ChronoLogic will be in Hong Kong on September 8th on Ethis. Piotr will be speaking alongside Vitalik and others, and we were pretty psyched about it. And the other one is ETH Berlin, at which ChronoLogic will be partnering with Polymath on one of the hackathons. And so, stay in tune for this kind of stuff on our Telegram channel and on our Twitter account. So another thing that we wanted to remind you guys is that scheduling is now live on the mainnet. So if you have any use case for scheduling, if you have something that you want scheduled, we do have it running on the mainnet, and we do have mainnet time nodes up and running. So you guys can run your own as well, and you can start scheduling transactions. You don't have to wait anymore. You don't have to do anything. You can just go ahead and schedule if you go to app.chronologic.network. So this is in preparation for the MyCrypto release. You don't really have to wait for MyCrypto to integrate mainnet scheduling. You can just do it straight away on app.chronologic.network. Another thing we added is we added a download section to the Ethereum alarm clock website. So besides going to our GitHub channel and downloading the executables for Electron DApps and all this kind of stuff directly from our GitHub, you can now also go to ethereumalarmclock.com and press the download app button on the TimeNode section, and this will kind of, we're hoping kind of that people will get more exposure to these TimeNodes through the Ethereum Alarm Clock website, and they will start downloading and using these TimeNodes as much as I'm pretty sure you guys are as well. So we have another thing for you guys is we have an update coming soon to the TimeNode to the Electron time node and to app.chronology.network. And this upload is a pretty cool one. So it is a new improved dashboard, which includes a lot of the details that were not previously visible on the time node. Even though it is still subject to change, I figured I might show you guys a short demo of how it's actually running. So I have it running here on my time node, on my local time node, using the Robson network. We have set up a scheduler bot, thanks to Logan from our team. So Logan set up a scheduler bot that schedules test transactions on Robson. It schedules a couple every couple of minutes, and you guys can use this to also, if you're not ready to go live to the mainnet yet, you can of course use this on the testnet as well, and you can see how it's actually working. So this update is not live yet, but hopefully this will give us better insight into some of the statistics we have in regards to the time node. So we have our regular stuff, we have our profits here, we have our balances here, and the number of executed transactions. You have seen this all before, but what we have added is an actions tab, which shows the amount of executions that have happened, the amount that has succeeded, and the amount that has failed, the amount of claims that have happened, the amount of that succeeded, and the amount that failed. And this is looking pretty promising. So hopefully you guys will really enjoy this kind of statistics. Another thing we added is a summary where you can see how long your time node has been running. You can see the amount of transactions your time node has discovered, and you can see some other pretty cool stuff. And here you can check every claim and every execution in detail. So whether it succeeded, whether it failed, whether how much was the reward, how much was the bounty, and all this kind of stuff. So you guys are excited about this update as much as we are. So stay in tune for this update. And
yeah,
that
Joseph,
brings us
one thing, Joseph. I think we missed one slide. I don't know if you want me to take the presenter thing, or
sure.
you wanna refresh. Let me take the presentation, okay?
Sure.
We just missed like one of the I think the important stuff now. So guys, first of all, do you hear me and do you see my screen? There should be the release plan. Let me know in the question box. Okay, cool, thank you. So guys, so yeah, I know a lot of you have been asking, what's the release plan, what's the roadmap, and so on and so forth. So we obviously keep working on that, and there is like a lot of moving parts, and the crypto market as a whole is not in the tip-top conditions currently. So we kind of wanna take this into the consideration as well. But I wanna throw at you a couple of these dates that are going to be actually very crucial and play an important role. So as Joseph said, mainnet is up and running. We did that actually like a week ago or 2 weeks ago. It's important for us. So we run the time nodes, we observe how does it work, how the pool scanning works, and so on and so forth, because the mainnet is not the testnet. So that's important for us for testing. Also, as Joseph said, at ETHIS on Saturday, I'm gonna be presenting the second layer execution markets, but I'm gonna also I will have the slides, and you will actually see that in my presentation. But we're gonna do the first announcement about the mainnet release for the Ethereum alarm clock. So we're super excited about this. And there is a couple of things that we're working on. And the live stream of the MakerDAO is, I think, is basically done and scheduled. So in few days, next week actually, you will have the joint webinar live stream with MakerDAO. We're working on a MyCrypto joint live stream with the ChronoLogic, and actually MyCrypto release to the mainnet is planned on 14th of September. So hopefully you enjoy that as we are. We wanted to put this a little bit earlier, but given the MyCrypto release cycle every 2 weeks, the last Friday was basically too soon, and we're aiming for the next Friday in 2 weeks. So and yes, so this is not like a as you may see, like a proper launch. We call it a soft launch. We want to just take, organically, just keep, growing the TimeNode network and, spread the news to the developers, other projects, and so on and so forth. But essentially, the grand Ethereum alarm clock launch is going to happen near the DevCon 4, which is going to be in November. So yeah, I think that's it from the updates part. I'm gonna now switch to my presentation. Let me put this on the full screen. Okay, so I think everyone's ready to go. I guess I don't need to really introduce myself at this point. I'm gonna obviously do that at FIS, but let's jump straight into the slides. Oh no. So let me hold on 1 second. I think there is some sort of autoplay, which I don't like at all. Okay, let me see. Hopefully it's not gonna change. So yeah, guys. So yeah, before we actually can talk about the, the second layer execution markets, we need to understand what is the delegated execution, because this is the basis of the execution markets, right? On a high level, it is just a simple pattern that allows any third-party agent to execute transactions on your behalf, usually in exchange of the reward, right? So these agents are not altruistic, they are rational agents, so they will only execute and probably exist when there is a reward, or at least the coverage for their costs. So yes, so I mentioned that there are a couple things, and basically we are talking about the off-chain executing agents who are incentivized by the rewards, and they, on a high level, they execute some sort of payload, which is a data plus conditions, right? So this is generic pattern for that some projects are using it. In the case of the Ethereum alarm clock, we're using that where the conditions are the time of the execution. So whether this is a time or block, this is a part of the conditions. We also working on another protocol called Chronos, which is gonna generalize the conditions. So you can also, besides putting the time, you can also put any condition for the state or events. So the delegated execution is essentially, we can see that in two ways. It's either a deployed smart contract on chain, how it's actually is working with Ethereum alarm clock, or it might be represented as a sign message. So these are two different, representations. Essentially, the delegated execution work with both of them. So there are a couple of the differences, obviously, with a price of the implementation, the price of the scheduling or delegation, and with the complexity of those markets. I'm gonna talk about this during the next slides. So yeah, execution market. So we know what the delegated execution is, and essentially we have a multiple time nodes, or we call it time nodes in the Ethereum alarm clock, but more general, these are the execution agents. So because the delegation is open and it's incentivized, we are observing the market who is created by those executing agents. So yes, it's decentralized. It essentially provides the reliability for the protocol. For in our case, we can say that the more time nodes on the market, the more reliable the execution, for your scheduled transactions. On the other hand, we can see at this execution market as a, supply of the execution agents and a demand who is represented by. Oh, sorry guys. So I need to turn this off. Give me a second. Okay, let me see how I can do that. So I guess it's gonna autoplay again. Yeah. Well, that's not this presentation. Okay, so sorry for that. Hopefully it's not gonna be a problem at this. So we have like execution agents, which are the supply for the market, and the demand is represented by the bounties. So we are, the equilibrium for this market is that, assuming these are the rational agents, we're gonna keep up as much as TimeNodes, as much as the bounties or the rewards is gonna be available on the market. So this kind of market also, we can say, have a couple of these characteristics of the perfect competition markets. Essentially, everyone on the market have the same information. Everyone serves the same service for the market. So that might mean that the long-term earnings gonna just trend towards like minimal earnings. So sorry for that. I need to fix it. Okay. So yeah, a couple of the use cases. So essentially, Ethereum alarm clock is not the only protocol that is using the delegated execution. We have also a couple of the other projects like Gnosis, who is using that just to provide the multi-sig operations cheaper. Transaction relays by Uport that are actually allowing the people without Ether to cooperate and work with the Uport identification system. Recurring payments, mixers, which is kind of interesting. Also, I think it's gonna be used by the watchtowers, both for the plasma and for the state channels. So yeah, we said that there are a couple of the projects using that, and what we, I think, unfortunately observed as far as today is we kind of see multiple protocols and DApps implementing the same delegated execution and actually running their own time nodes or the executing agents around those protocols. So I don't think that's actually a efficient way to kind of serve this market. And let me explain why. Because essentially, I think we are creating the silos for those execution markets. So the fragmentation around those markets. And as we know, is that essentially the amount of nodes is proportional to the amount of bounties. And the less nodes means worse reliability. Also, these kind of markets are not as trivial to set up. You need to incentivize, you need to build your community, you need to teach people how to run the time nodes, how to run the execution agents. And the I think very important thing as well is that if we assume that there will be a couple of these executing agents running there, we might see that people who are running those protocols are not gonna deliver the fully decentralized protocols, because I don't think these executing agents should be run by the protocols or DApp creators. What I think we should end up, and this is obviously something that we think is going to be very beneficial for all the ecosystem, is that we end up with a homogeneous execution market run by multiple generic execution agents. So regardless the protocol or the DApp, it's going to be very easy to join and take advantage of this delegated execution pattern. So what's the goal? Essentially, we need a couple of things upfront if we think about running this kind of market. So one of the most important thing, I think, is the interfaces for the off-chain and the on-chain representations. We have some EIPs and ERCs, that's trying to get there. Also, I think, which is very important, is how we, the problem of the bounties representation. We maybe, there is multiple assets on the Ethereum network, so I think this should be like very, easy for people to choose. And if we want to improve on the decentralization, we should have many executing agents implementation. Also, as I mentioned before, easy onboarding for the newcomers. Okay, so that was like the general idea on the generic execution market. And because it does take some effort and some work and experience to get there, there are like three different categories of things that I want to show you and explain. So we have essentially incentivization, and we have two different variations, which is first one is deterministic execution case, which means that we know when the transaction is supposed to be executed. And like, with the scheduling, we know exactly at what block or what range of blocks or what time the execution should happen. So even though we know that, actually there is no 100 guarantee for the execution. So we're talking about the crypto economy guarantees, and that is turned down to essentially the amount of the bounty or the reward that is set by the person who schedules, and the availability of the time nodes. Also here we kind of talking about the budget, especially in the future execution, since you don't really know the gas price in the future, and you don't really want to like make those transactions not executable. So essentially the gas reimbursement might not cover the real gas execution. So this is something that the executing agent might essentially put from their pocket, which is a part of the reward. The other case is the non-deterministic execution. So we're talking here about the conditional execution based on events. You can actually imagine that as something like a decentralized stop-loss mechanism, where the executing agent is watching on the state of the blockchain, might be some oracle with the price, and then act upon that information. Here, one thing that might be interesting to research and see how that's going to play out is actually the notion of the rents for those watchers. Because essentially, because of the non-deterministic nature of this execution, you don't really know when that's going to happen. So might be better incentivization to pay those watchers over the period of time or per block, or whatever kind of time that is passing by. It does have a couple of the problems, obviously, because the watchers are incentivized to essentially watch forever, and they might withhold those executions. So there is a arbitrary arbiters needed to sort of this kind of things. Yeah, couple things about the bounties. So because we have multiple assets on the Ethereum network, Ether, ERC20 tokens, NFTs are everywhere, crypto kitties. But what about putting the reputation boost or the execution of the other transactions as a bounty? Essentially, what we're thinking here is that we should define some sort of interface for the MetaPayments that's essentially gonna allow any asset transfers in exchange of the delegation. Okay, so the second part is the communication. We have two variations for that. So we have the on-chain one and the off-chain. On-chain, well, essentially is using the smart contract storage to keep the place and to represent those transactions. We have a couple of the variation here. We can use the events, only events plus external storage and smart contract storage. It's always about the trade-off, about the complexity and the gas price, essentially. So yeah, the off-chain one. So this is the communication that we need to consider when we talking about the signed messages. And since we are not using the storage to keep them, on chain, we need to have some sort of storage persistence. Obviously, perfectly would be something like IPFS Swarm, decentralized storage, but we also need a messaging layer, maybe some sort of publish subscribe. And one note is that in case of these delegated executions, I think essentially the destination is always the chain. So in case of the scheduling, because you wanna, if you wanna send something on chain, you just kind of take off from chain. you might go with the signed messages. You can, or just again represent your transaction in a smart contract, but the target is usually the chain. Yeah, and the last part, I think very interesting, is that, well, the coordination games. So yeah, so why actually we are talking about the collisions? Because what we're doing here with the delegated execution is that we incentivize multiple agents to work for us, but we do this by default in a uncoordinated way. So the only action that is rational is to just observe in the on-chain variation, observe the chain and see if there is already some execution happen. If not, try to attempt those executions. Which means that, and this is basically not a zero-sum game, so some executing agents will lose Ether or whatever asset, Ether because they pay for the transaction gas cost, and just only one can basically earn something. So yeah, we actually, so there is a need for the some sort of form of the coordination, and because it's on chain, it's really you can figure out some fancy algorithms to coordinate, but essentially that means the cost of the coordination will be too high, which actually kills the purpose. But as a good example is something that we have in the Ethereum alarm clock. It's called the claiming mechanism that allows people, the executing agents, to pick the profitability point, and that's essentially it's because those agents assuming that they are rational, they won't claim transaction that renders them are not profitable. So, and because everyone have some different running cost, it just helps us avoid the collisions. The other idea might be the priority cube, based on the stake, that is just gonna allow just the most staking executing agents execute more often. Yeah, with the off-chain part, essentially what we're thinking is that the off-chain coordination games have very similar problems as the Casper block producers. And we were thinking about the on-chain staking with a random sampling to pick, who's gonna execute those transactions. One of the problems is that essentially, and as a specific case for the scheduling, you want to take this coordination game very close to the execution, not like time ahead, because you don't really know when the thing is gonna happen. So yeah, that was about the second layer execution market. The very good example, as mentioned before, is the Ethereum alarm clock. And I just want to make a small announcement. We are available on the mainnet, so you can go to appchronologic.network. You will see our DApp. You can just go there and schedule transactions. Soon we're gonna be available on my crypto wallet as well. And if you are interested in running the executing agents we call TimeNodes, just go to www.ethereum-alarmclock.com. You will get the instructions and tutorials how to get it running. And this is a sneak preview on how the my crypto is gonna look like. So thank you for your time. Hopefully you like it.
Thanks for the awesome presentation, Peter.
Yeah, I just need to kill my PowerPoint because of this, playback thing. I don't know.
Well, you guys know the drill. So follow us on Telegram, follow us on social media, and we'll keep you guys posted. We'll keep you posted on Ethos and on ETH Berlin, so you guys can see how everything is going, and stay cool. Cheers.